stress and strain. When a body is subjected to a deforming force, a restoring force is developed in the body. This restoring force is equal in magnitude but opposite in direction to the applied force. The restoring force per unit area is known as stress. If F is the force applied and A is the area of cross-section of the body, magnitude of the stress equals F by A. The SI unit of stress is Nm raised to minus 2 or Pascal, PA, and its dimensional formula is ml raised to minus 1, T raised to minus 2. There are three ways in which a solid may change its dimensions when an external force acts on it. A cylinder is stretched by two equal forces applied normal to its cross-sectional area. The restoring force per unit area in this case is called tensile stress. Tensile or compressive stress can also be termed as longitudinal stress. If the cylinder is compressed under the action of applied forces, the restoring force per unit area is known as compressive stress. In both the cases, there is a change in the length of the cylinder. The change in the length, del to L, to the original length, L, of the body, cylinder in this case, is known as longitudinal strain. If two equal and opposite deforming forces are applied parallel to the cross-sectional area of the cylinder, as shown in here, there is relative displacement between the opposite faces of the cylinder. The restoring force per unit area developed due to the applied tangential force, the strain so produced, is known as shearing strain, and it is defined as the ratio of relative displacement of the faces, del 2x, to the length of the cylinder, L, where theta is the angular displacement of the cylinder from the vertical, original position of the cylinder. Usually, theta is very small, tan theta is nearly equal to angle theta. A solid sphere, placed in the fluid, under high pressure, is compressed uniformly on all sides. The force applied by the fluid acts in perpendicular direction at each point of the surface, and the body is said to be under hydraulic compression. The body develops internal restoring forces that are equal and opposite to the forces applied by the fluid. The internal restoring force per unit area in this case is known as hydraulic stress, and in magnitude is the strain produced by a hydraulic pressure is called volume strain and is defined as the ratio of change in volume, delta V, to the original volume, V, volume strain, V by V. Since the strain is a ratio of change in dimension to the original dimension, it has no units or dimensional formula.